Good morning, everyone. Welcome to Dreamforce. My name is Josh Kaplan. Thank you for coming to the session to talk about continuous integration on the Salesforce platform. I'm going to walk you through some of the ways that people do continuous integration today, some of the options you have available to you. And I'm also going to talk a bit about the new Salesforce Developer Experience project that we've been working on, which will provide you some new tools to make it easier to do some of the continuous integration work that you're going to do. I'm a little nervous because I've seen at least one person in here who has built a more complicated continuous integration system than I'm going to talk about today, but hopefully what I'm going to do is going to be useful for everyone here. Before I start, too late, I have to show you this slide, of course. I'm going to be making some forward-looking statements. Please make all purchasing decisions based on publicly, currently available. Go ahead and read this online. It's actually kind of funny if you read it in the middle there, but we'll get to that some other time. What is continuous integration? Start with the definition. Part of the issue that I've had as we've been working on this is that if you go to try to find a definition, you'll find if you ask 15 people, you get 15 different answers. Everyone seems to have a different definition of what exactly continuous integration means. It sometimes overlaps with continuous delivery, continuous deployment, and different things that are related. So I thought I would try to start with a general definition, which will guide the talk. I'm sure it'll be different than somehow some of you would define it, but this is kind of how I've been thinking of it. Continuous integration is a process you set up to make sure that every change you make to your system is compatible with the rest of your system. So that when you make changes to your system, you're going to deploy them into a production environment for the users in a safe and reliable way. So it's a process you set up to make sure that what you are doing doesn't break across the rest of your project, so that when you work in isolation, things look great, and then you get into production, they break crazily because you didn't test it. Continuous integration is the way to ensure that what you are doing is going to work across your application. Does that jive with everyone else's, hopefully? Close enough? Like I said, it's going to blend with continuous delivery and continuous deployment a little bit, but we'll go with that. So what are the principles? What are the principles of continuous integration? I think the primary thing is that your build is never broken. You're going to set up automation in such a way that when you make changes and when you submit them to be part of the global application, you won't break the build. We're going to set things up to make sure that doesn't happen. The first thing you need to do is you need to write a lot of tests, lots and lots and lots of tests. As the Apex product manager for years, I've been telling everybody to write lots and lots of tests, and I get to continue doing it as I talk about continuous integration. Write lots of tests. These are your sentinels. These are the things that stand in the way of somebody making a change that breaks your code. This is the thing you need to make sure that as you move forward, nothing that someone did 5 years ago is going to be impacted by something someone's doing today. Lots of tests, many types of tests. Next thing you're going to need to do is you're going to need to instill some new behavior, some new ethos among the team, perhaps. They may not have worked this way in the past. They're going to need to do a couple things. They're going to need to check in their code frequently. No 5-week-long things with 700 files that make the walls creak when you try to check it in to the system. Frequent, daily, twice daily even, more frequent check-ins to the code so you don't diverge, so you don't end up on such a faraway tangent that when you find some conflicts, you've got to unwind all the way back just to fix them. You want to catch those things early. You want to catch the differences early as you go forward so that when you do get to the end of the road, you're not so far astray from the path. You have to make that, I believe people call it integration hell. And then you have to run the tests often. So as you're checking in, be running tests, running not just your tests, but everybody's tests. Make sure that it's happening so that you don't break anyone else's work. And as I mentioned before, the build is never broken. So when there is a problem, bad news needs to travel quickly. Information needs to get back to your developers right away that there is a problem, something that they are going to need to fix. And as soon as they get that information, they need to fix it immediately. So we don't want people to be putting things into the build that are going to cause problems. We need to get the information to them so that they can act on it and they can make the necessary changes so that we have a safe application. And what is the point of all this? It's safety. It's a trustable application. Trust, we say at Salesforce, is our number one principle. It should be everyone's number one principle. You want to make sure that the application you're delivering and the changes you make in that application are going to be safe. They're going to work. They're not going to break. So this is all about reliability. This is all about dependability. It's all about a new set of processes to make sure that what you're doing is going to be safe and reliable. I mentioned tests before. Lots of tests, lots of different kinds of tests. And I want everyone to start to embrace all the different kinds of tests you're going to have. You've got Apex tests. You've got UI tests. You're going to have API tests, mobile application tests, integration tests, performance tests, user acceptance tests. I sound like Bubba from Forrest Gump. We got barbecue tests. We've got test gumbo. Lots of kinds of tests. Whatever your application is doing, you need to be setting up tests to do that. These may not all apply. You may not have any integrations. You may not have a mobile application to test. But if you've got any of these elements, you're always going to want to set up enough tests for every single part of your application such that nothing's going to hurt in the future. Things like performance tests are especially important for this. Things get really slow all of a sudden. You need to know that in advance. You need to know that the thing you put into place had an infinite loop in it. It's a good thing to know. So performance tests, benchmarks, all these kinds of tests are going to be useful, and they're going to help you with that safe application. I can even further break these down into unit tests and white box tests and black box tests. Lots of different ways to look at tests, embrace them all. Use them all and make sure that they're standing there to make sure your application is good. There's different things you're going to need to put in place to make continuous integration work. Some of these are kind of specific to how things work on the platform, and some of them are just generally going to be true. You need a strategy for your environments. This is a big one for Salesforce. You need to make sure that the environments you are using for your test and for your development look a lot alike. They look like your production environment. Make sure that they're aligned. You need a version control strategy. You need a place to store all your changes, track all your changes, roll back when you make mistakes. You need to automate your tests. As I said before, we want to run tests frequently. We don't have to keep clicking the button. We need something to do that for us. All the tests we mentioned before, we need to group them. We need to be intelligent about how we don't want to have one giant battery of tests. We want to have lots of small sections of tests so we can effectively test things when we need to. And you're going to need a branching strategy. As you get to a large team, you're going to have a good strategy for how you work your code from idea into production. So I'm going to drill into each of these, and we're going to go through some examples, some simple examples, a little more complicated examples of how this can work on the platform. First, we'll talk about the environment strategy. It's really important that the tests that you're running are running in an environment that looks like your production environment. That should make sense, right? That should be kind of, when you think of it that way. If you're running tests in something that's not like your production system, you're going to miss some stuff. If you're running tests in something that's not like your development environment, your developers are not going to be able to reproduce the things that you found in the tests. So these environments need to align. You need to make sure that everything's apples to apples across the board. As I said, this is difficult with Salesforce in some sense because the environment is so central to the application, the org. The org has always been the center of all things. We're working on moving away from that. When we get to Salesforce DX, the org will no longer be the center of all things. Your source repository will be the center of all things, and the org will just be the container in which you run. But we need to pay attention to the container. We need to pay attention to the environment and make sure that it's aligned. So the consistent test results, as I mentioned, and then you want to make sure that when you do deploy from that test environment into production, that you can be certain that the thing you're deploying is what you tested. At a high level, what you're probably familiar with, if you're in a customer environment, you'll typically be working with something like this. You have a developer sandbox that the developer is working in, another sandbox of some sort, whether it's full or whether it's dev for testing, and then promotion up to the production environment. If you're in an ISV, if you're a partner, you're probably working with something like this, with the developer edition org for your developers, also a developer edition and org for your testing, and a packaging org instead of a production org, which is where your end goal of everything is, which is also a developer edition org. Very nice how it lines up. So everyone's familiar with this. What we're going to be working towards with Salesforce DX is to be replacing with what we're calling a scratch org. A scratch org is an org that's going to be built from scratch. It's going to be empty. It's going to have nothing in it to start with. And it's going to be populated by your application in source control. So this is going to be a way to make sure that these things are always aligned, right? Because if I'm using the same scratch org in both testing and in development, it's going to be the same. If I deploy from a version control system, it will be the same. So we're working towards providing you a new set of environments that will make continuous integration a lot easier as you go forward. So today, you're working in the sandboxes and the DE orgs, and in the future with Salesforce DX, scratch orgs will be your ticket. All right, so once you have an environment, whoops, go back. You need a version control strategy. So continuous integration without version control is a bit to me like a bicycle without a seat. I'm sure it would work if you really wanted it to, and clearly from this photo, someone has manufactured such a thing. I don't think I would want to do that. I won't go very far on that bike. I might try it once and say thank you, no thank you. When it comes to continuous integration, version control is something you need. That's just prerequisite. If you don't have a version control strategy, we're going to need to get one. Go find the latest and greatest Git or whatever product you want to use. You need a version control strategy in order to make the next step work, which is automation. So in order to be effective with testing things, you're going to want to run tests frequently. We got lots of tools out here. I use the Jenkins logo because I think the logo is cool. But there's lots of tools. There's Travis and TeamCity and Circle. There's tons of CI systems out there that will do a lot of the heavy lifting for you. It will allow you to do much more than you could do if you asked your developers to go click the button every single time. So the first thing that we're going to ask it to do is to run tests on every single check-in. So anytime someone checks something into source, which we said earlier they're going to do once, twice, 3 times a day, we're going to run a lot of tests to make sure that what they've done hasn't broken. And we're going to have an automated process take care of that for us. Our version control system, which we already established that we have to have, is going to have some API hooks that are going to tell Jenkins or your CI system that a check-in has happened, which will allow it to kick off its process. Salesforce DX is going to be providing a new command line interface to make this work much easier. The command line interface is going to be an aggregation of all the different API commands you've used across all of our different APIs. Again, I'm going to sound like Bubba from, we got the developer API, we've got the metadata API, we've got the tooling API, we've got the packaging API, we got all these APIs. And you have to use all of them. They're all going to be in one place. The command line interface will combine all the things you need from all those APIs in one sort of meta API, if you will. It'll be able to be consumed by an automated process system to do things like spin up orgs, run tests, etc. Now, it's important to note that Apex tests are not unit tests. If you're running something like Java or Node.js, you can sometimes have a test run in a simple VM somewhere else and it even gets taken care of sometimes by the source control system. But Apex requires the entirety of the environment to be spun up. You can't just do it on a simple virtual machine. You need to spin up a whole system. You need to deploy it into an org container in order to make the test work. So it's not quite as simple as some development in other places. So on the platform, we do have this nuance that we need the full, we don't have really unit tests. We only have that white box and that black box type of testing. Therefore, the next step that Mr. Jenkins is going to have to do is going to have to establish an environment. He's going to have to make a place to put the code. So we're going to have to find our org, like the previous slide said, it's a scratch org, it's a DE org, it's a developer sandbox. Find that org that we're going to use for testing that looks like our other environments. Populate that with the appropriate metadata and do it in a consistent way. So make sure that the process you're using to deploy into this new org is the same process you plan to use to deploy into production. Because we want to make sure that when we take that next step, there are no hiccups, that there are no unexpected problems. I'm going to keep saying this, you got to keep the build clean. So tests have to pass before you merge. We don't want to merge until we've run these tests. We spin up an environment in between the process of trying to check into the main branch and actually committing to the main branch. Tests have to run, make sure that everything is good before we promote. And of course, if we didn't get everything right, we want to tell the developer as quickly as possible so that they can fix the problem. So these are the kind of the 3 principal things you have to have. You have to have your environment set up, your version control, and your automation set up. So now let's take a look at some simple examples, and we'll get a little bit more complicated as we go forward, of how we can set this up. In a simple world, one developer, one org, not very much going on. The developer will use a developer sandbox. They're going to go in, they're going to write some code, make some metadata changes, they'll run their test locally on that particular sandbox, and then they'll commit to the version control system. That check-in will wake up your automated CI system, which will take another developer sandbox that it will refresh so it looks like the production org. It will similarly deploy changes into that org and launch that same, or the complete suite of Apex tests. We'll talk about the difference between the local tests and the tests being run here at a couple slides later here. But the idea here is that I've got a different environment set up for my developer, a different environment set up for testing. Both came as refreshes from the production environment, so they're going to be very similar. I'm pretty certain that things are going to be the same. And now when I'm done running the test, if everything's good, I'll be able to promote that same set into production. It's a really easy case. If it were always this easy, we wouldn't have needed this session. You guys wouldn't all be here. So I wanted to start with this as a baseline. So in the world where there aren't enough sandboxes to just constantly refresh sandboxes to your testing, the developer is going to do the exact same process. Take the developer sandbox, write their code. VCS is going to kick off a message to your CI system. It's just one option. This is not the only option. But one thing people do is they'll reuse the developer sandbox. So instead of refreshing the sandbox, because you can only do it once a day, clean it out. That could mean deploying code from a previous version. It could mean undoing metadata changes. There are some scripts you've got that people have written out there that will do this, that will take your org back to a previous state. It's not quite as clean as refreshing from production. It's a little bit more, eventually, right? Like you push a button 100 times, eventually it's not going to pop quite up to the exact same level it popped up the first time. So there's going to be a little bit of a difference here than having a fresh, clean refresh that we had in the previous idea. We clean up the org before we deploy changes to it and run our tests there then. So just a different way of doing the exact same thing to get our stuff into production. Simple flow for an ISV. If you're building a managed package, instead of using a sandbox, using a DE org, still running your code, still committing, still kicking off that build. But what environment are you going to use for testing? You could use another DE org. I suggest you use a trial force org. Why do I suggest TrialForce org? Sandboxes are refreshed, they're collected, they go away. TrialForce orgs expire after 30 days. DE orgs live for a long, long time. So hopefully you're going to walk out of this room inspired. You want to do more CI. I don't want you to go out and spin up thousands of DE orgs. That would be bad. So if you can have access to TrialForce, you can use those to get lots and lots and lots of them, and they'll collect themselves after 30 days. So good option here is TrialForce. Deploy your changes, and then instead of promoting production, obviously, we promote the packaging. Simple flow for the ISV. But now the world of Salesforce DX. You guys heard about Salesforce DX? This is the first time anyone in this room has heard of it. You guys all heard about it the last 24 hours, I hope, a little bit. Like I said before, we're trying to change the process a little bit. We're giving you some more tools you can use. I mentioned the command line interface. I mentioned the scratch org. So the big change is the first step for the developer is not going to be to go get themselves an environment. It's going to be to write code. You don't need an org to write code, do you? You need a text editor. You need an IDE. So if you've cloned from your version control system, you can just write your code right there in Eclipse or whatever tool it is that you're using before you even have an org environment. And then when you're ready, like you do with Java, you type your code. When you're ready, you click play. You click the play button at the top, and that spins up an app server that runs the code that you've written. That's the way most application systems work. We're endeavoring to make platform programming much more like that. So once you're done writing your code, that's when you're going to spin up that environment. You're going to press the play button, just like you do for other languages. You're going to spin up that scratch org environment. This scratch org is just going to be for you as a developer. You're the only one that's going to use it. Nobody else is going to use it. You're going to have the only user log into this org. And you're going to deploy your changes, your particular things you've worked on from your local machine to that scratch org. A little different process. Process today, you spin up an org and pull everything down from the org, which is kind of backwards. This is the more normal, straightforward process that people are probably more accustomed to. Going to run the test, commit to source control, and then Jenkins will be kicked off again. What kind of environment is Mr. Jenkins going to spin up? Scratch org, identical, same as the one that the developer was using. And then the deployment is going to come directly from the source control system, from the commit that was just made, the pull request that was just made, and it's going to deploy this. So it's exactly the same. I'm going to be running my tests in the same environment. I don't have to worry about, did I refresh this? Did I clean everything out correctly? It's going to be identical, and my process is going to be cleaner. It's going to be more reliable, it's going to be more consistent, and my application is going to be stronger, and everyone's going to be happier. Launch your test, promote your production org, we're happy. So those are the basics. You need a version control system. You need to know about your environments. You want to make sure the deployments you're doing from place to place are the same, that they're consistent. And all the tests that you have, you want to run them so that you make sure that you don't check anything that's going to break. That's why we're doing all this testing. And then you're going to make the boss happy. You're going to have a trustworthy application. Things will be good. So hopefully this is making sense to everybody. I may be still behind a lot of you. A lot of you are probably saying, I've already got all this. So we're going to keep moving forward a little bit here. So in an inconsistent world where I really can't be sure that all of my environments are the same, I still want my deployment to production to work. I never want that to fail. I never want to find out that that last step is the one that is going to trip me up. So what you can do is you can add another environment to your process. You can add a staging environment. The staging environment can be used simply for the purpose of staging a deployment prior to deploying into production. This will give you one extra added level of security in what you're doing. So the process is the same. Developer going to make a change. Mr. Jenkins or other CI system is going to spin up an org, and it's going to do its tests. This could be any of the permutations we described before. Before we're ready to promote to productions, we're going to ask Mr. Jenkins to do one more thing for us, which is to get a sandbox. It can be a full copy. It can be a dev sandbox. It's not all that important. But let's get a copy, and let's refresh it right now. So let's have a current world version of what production looks like before we try to deploy to production. Let's deploy our changes into that staging environment, and let's rerun all the same Apex text we ran. If and only if that's successful, are we going to kick that into the production org. So this is a layer of added security you can add to your process. Some of you may be doing this now. I know some of the customers I've worked with in the past have been doing this. I know some that have not. This may make sense for you, it may not. It's one additional thing that you can do with continuous integration to get to that goal of ensuring the changes are good. You also want to bring your users into the process, because you got product managers like me who want to look at the thing and make sure it does what I thought it was going to do. And you've got business users who want to make sure that the math is the way they thought the math is going to be in the new little grid control that you built. So we need to bring our users into the process. So what are we going to do here? Exact same thing before. Developer is going to be in a scratch org. Tests are going to run a scratch org. But now we need to get access to that change to all of our users. For this, I want to use a sandbox environment when I can. I want to use the sandbox because, as I mentioned before, these scratch orgs are temporary. They're only going to live for a little while, and they have no user set up in them from start. They are only built from what's in source control. I don't think anyone puts their users into source control. I hope not. Maybe there's a reason. Sandboxes always get the full user table. So if I clone a sandbox, all my users are going to have access to it. So I use that sandbox environment, probably refresh it before I deploy things to it, and I take my release candidate and I deploy it there for everyone to use. So the scratch orgs had their use. They were done for used for development, and they were used for testing. But if I want to get everybody to access this, I still kind of want to be in that production style environment, in that sandbox environment where everybody can access it. It also has the added benefit of being a pseudo deployment to production, like our staging environment. So user tests can run there, and if we need, we do what we call internally a blitz, which is everyone just goes in and beats the thing up for 2 hours, 3 hours, and logs any bugs we find. You can do that for a week, you can do that for a day, however long you need, but it gives users access to the process before you start doing your pseudo deployment and your actual deployment to production. Yet another kind of tests, critical kind of tests in a lot of different environments. Some environments not as much, but most times when you've got a business user who asks you for something, they'd like to see it before it goes out to make sure that it matched what their vision was. Get them at the end. Talk at the end. So for the ISVs, instead of your users being brought in, we're going to bring your subscribers in. And I've been calling this the multiverse. What is the multiverse? Every single one of your subscribers has their production org. And every single one of your subscribers has a slightly different production org. Some of them are going to be professional edition. Some of them are going to have multi-currency turned on. Some of them are not. Some of them are going to have chatter turned off. Some have service cloud licenses, some don't. There's going to be quite a wide array of different types of orgs that you are going to be pushing your package to. I call this the multiverse. So another step you can add to your process before you promote into your packaging org is to add this in. So you write your code. Your CI system then does the work of running tests at it. You have a release candidate. You want to upload this to the App Exchange. You want people to use it, but you want to make sure it's not going to break anybody. You've tested it in your D, in whatever environment you've got set up on Salesforce there, but you haven't tested it across them all. So we're going to ask our CI system to spin up a bunch of different environments. All the special snowflakes out there are going to be brought into place. We're going to run the same battery of tests against all of your different customer types, or at least all the major permutations you care about, because time and resources are finite, but you're going to run the test not just once, but some larger number of times. We just had a case not too long ago with a partner of ours who had this exact problem. They deployed a change, they ran all their tests, they had a very complicated CI system in place, but they missed something that only was a problem in one subscriber's org because of a certain thing that they had turned off, and they had to release 4 different patches to get the thing up to working again for that particular customer. This will help you avoid it. Scratch orgs are going to be critical in making this work. Scratch orgs, because they're built from scratch, they start with no configuration whatsoever. You're going to apply the configuration to it. If any of you worked with trial templates before, it's similar to that. You can say, I want to turn this permission on. I want to turn these license types on. Scratch orgs can become any kind of org you want them to be. That's how they're going to be useful to all of you, because all of your orgs are different from everybody else's org. And the scratch org is going to be the way in which we allow you to apply your unique configuration. It's going to be useful for customer cases as well. You may want to turn chatter off in your org. You may want to turn chatter on in your org. You may want to run tests against both configurations before you release a change because you know what's about to happen. You may be about to subscribe to Service Cloud, so you need to run your tests in without and with Service Cloud to make sure these changes are not going to break as soon as you turn it on. It may be the 3 times a year where we do a release upgrade, and you want to test both in the current version plus the version that's coming up in three weeks because your release schedule may not precisely align to ours and you want to release some stuff 2 weeks before the cutover. You want to test it, how it's going to look in the new one as well. So the ability to change your environment configuration and run tests against different configurations is going to be useful not just for ISVs, but for customers as well. Every single one of these steps is going to feed back into development. It's important to remember that. The process is not linear. If you find a bug in your testing environment, it feeds back to the developer and has to go through the whole process again. If you find a problem, print UAT, it goes back to the developer, has to go through the whole process again. If you find a problem when you're doing your staging deployment, it feeds back in, it's got to find its way up through the process again. You don't get to skip a step just because, oh, I was already at staging, so I get to, warp to level 4. You have to always do your full process the whole way through, and everything's going to be feeding back to your developers. In order to really support that, as things get more complicated, you're going to need a branching strategy. You're going to need something that's going to help you manage this process. And what I'm about to show you is one way of doing it, and this is going to be completely varied based on what it is that your particular environment is. So you're going to have to apply that lens to what I'm about to say. This is not a prescriptive thing. This is an example that I'd like you to sort of turn in your mind to point in the direction that your environment will point. So I have a branch for developers. So the developers themselves are always going to have their own branch where they're doing changes. I'm going to have a develop branch, which is going to effectively align to my testing environment. So my check-ins that are going into develop are being run through this testing environment. I'm going to have a branch that's aligned to my UAT environment. So whatever's in integrate, that's what I've got stored up in my UAT environment. I'm going to have a branch aligned to what's going into staging, which would be master in this case. I don't have another click for production environment because whatever I promote to staging, I'm going to then immediately promote to production, right? So they're going to be identical. I'm only using staging for the purpose of testing what's going to go into production. Again, your mileage may vary. Whatever you want to do is going to work. Process, very simple. When I want to start making changes, I branch from master. My co-developer makes a check-in. I'm on my branch. I make a check-in. My co-developer makes another check-in. It goes into develop, and the tests get run. Before I do anything, after my next change, I'm going to need to forward integrate. I'm going to need to take the changes forward from whatever other things have gone on, and I'm going to have to bring them down into my branch and do my testing before I push up a develop. This is how we avoid that creak the walls, that 7,000 file deployment being a problem. Every time I'm going to check in, I have to pull down everything and run my test locally. So if I've made changes that break something that happened in the interim, we'll find out in advance before I even check in. So we got my branches down there, which are and your branch, which are aligning to the developers. Check back into develop. Once we have a release candidate there, we bring it into integrate, push it into the UAT environment, and once that's clean, we're going to push it up into master and try to promote to production. So again, you can have more branches, you can have feature branches, you can have all sorts of craziness, but the way I've thought of this, it's made sense for me, is that each one of these branches aligns to a stage. It aligns to a part of your pipeline. So if you think linearly of how you want things to go, left to right here, from the idea going into the developer's mind and getting through safely to the users, or to the people who request it, and then to the users, if you have that process lined out and you can set your branching strategy up so that you know what's going on in each step in the process, it makes it easier to keep track. Again, there are many, many ways to do this. This is not the only right way, but maybe this is one that you can use and it will help you with your process. I keep talking about tests, running lots of tests. In the purest version of continuous integration, you really would run every test on every check-in. It seems like a lot. I know that since I've been shouting about writing lots of tests for many years, you've all written thousands of tests. In some cases, that's not even an exaggeration, thousands of tests. I spoke to a customer yesterday. It takes 6 hours for them to run all of their tests, which may be up there as one of the largest numbers that I've heard. But it can take a long time to run all these tests. So you probably don't really want to run every one of your tests on every single check-in. Pure CI would have you do that. We can find smarter ways. So we want to go from fewer tests on the left side of our diagram to more tests as we get to the right side of the diagram. I don't need to do everything. We have a basic set of tests, which is I want to validate that regressions aren't happening in the most basic sense across the whole of the product. I have an extended set beyond that maybe I'm running while I'm doing my feature changes, but we get to the left-hand side or the right-hand side where we're doing promotion to production, I need to run my full suite. I have to run everything. So we can do fewer tests at the beginning, more tests at the end. It's a long tail, right? It's a long tail effect where if you find a bug in basic, you got 50, 100 tests in basic and 500 in extended and 4,000 of them in full, one failure in basic is going to represent probably 100, 200, 300 failures in your full tests, right? So if you miss something up here, it's going to cause a lot of failures down there. So get that first set clean, then you'll find a bit of a long tail as you go forward. Each test will find you fewer and fewer additional problems. So you don't need to run them all the time. You do, however, need to run them all before you check into production. Don't ever forget that part. As you get into a broader team with lots of smaller sub-teams that are doing independent features, you may want to have feature sets of tests, suites of tests that are particular to your feature. So as you are in the early stages, yeah, you want to run basic for everything, but you may want to run a little larger set of tests on your feature. Why? Those are the tests you're a lot more likely to break because you are messing with your feature. So those are the ones you're going to get the most value from. We're thinking in terms of how do we get the most value from the test we run and get information back to the developer as quickly as possible, right? We don't want them waiting for 6 hours for their test results to get done to find out that there was a small failure. We want to have them run whatever is necessary to get the information back so that they can fix things. And again, there's lots of different types of tests. Things like the UI tests and the API tests, those are external tests. They're sourced externally, so they involve putting data into the system. They take more time to set up. They're a little more brittle because they don't roll back nicely like Apex tests will do. So in order to get those tests to work, there's a little bit higher cost. It takes a little longer to do. So you may want to push them out to a later phase in the process. You think intelligently about where am I going to get value from which tests? Which ones do I want to run now? Where in my process should I run them? So now that I've given you all of these immense set of ways you can do branching and tests and setting up environments, how are you going to manage that all? Salesforce DX is going to provide something we're calling the test runner. I'm betting we'll come up with a better name between now and the pilot of Salesforce DX, but right now it's the test runner. Doesn't look anything like that guy, but maybe. This application does a bunch of stuff for you. It manages environment creation. It has a bunch of different, you can specify in a JSON file the different org configurations you care about, what the permutations you are, what perms you want flipped, what licenses you want turned on, and it will create scratch orgs for you as a part of the testing process. It will load data, reference data, especially necessary if you're doing a mobile test or an API test, an integration test that's coming from the outside. So you load data in advance so that you have something to do your tests against. Test runner will help you load that data. It will manage the test suites for you. So once you've broken your suites down, you've done that thought experiment of what do I really care about running right now? What do I really need? Where am I going to get the most value? You can set up different test suites that you can use in different test runs. So you can say these environments, these test suites, that's the tests I want to run right now. Test runner will handle running, not just calling the simple command that says CLI command to run Apex, but it will hook into something like Sauce Labs to do Selenium tests, or we'll kick off a load test, like a load runner. We'll kick off whatever type of testing you want. It runs a command line. If you can run a command line, you will get that capability inside the test runner. And what I'm really excited about, this will set up parallelization. So if you're that customer that's running 6 hours worth of tests, wouldn't it be great if you could spin up 60 orgs and run like 1%-ish of your tests on each of those 60 orgs and be done in what, 60, is it 10 minutes, 6 minutes? It's shorter than 6 hours either way. So this will help you with parallelization. It will let you spin up not just one scratch org, but any number of scratch orgs you want and divide your tests out amongst them all. In some cases, it will even break the tests up for you. Sometimes you need to give us a little help because data setup in one set of tests is necessary. You can specify it, but it will even do, in the basic case, split up all the tests evenly across all of the scratch orgs that spun up. So not only will the test runner make it easier and let you save and store configurations and types of tests you want to run, but it's going to be faster. It's going to be fast like that guy. And kind of brings it again. I got one question already, so I want to let you guys ask me a few questions. But there's going to be a lot of ways to get yourself to a healthy application, and continuous integration is one critical part of it. What you do is going to depend entirely on your situation, and your success is going to depend entirely on how devoted you are to this, how dedicated you are to this, how determined you are to make it work. So why is this important? Remember that always. Instill that in your team. This is important because we are going to have fewer bugs. We're going to have an application that's trustable. We're going to spend our time instead working on new features. Get that discipline in there. Write a lot of tests and get the automation working for you. Salesforce DX is going to help you out. We've provided a whole bunch of new tools like scratch orgs, the new command line interface, which will make this open so you can integrate to any CI tool you want, and the test runner process to help consolidate the process of running tests. And that is what I have about continuous integration on Salesforce. Thank you very much. If anyone has questions, you can head to the microphone because we're recording this so we can get the audio for later. Any questions? No one? You had one question. You were asking about, it was, why don't we want to use the staging org to do user acceptance testing? Could we do that? We could use the same sandbox for it, but the idea is that you want the staging environment to be refreshed immediately before your test deployment. If users have gone in there and they've run user acceptance tests, they'll have monkeyed with the data and they'll have made some changes to it. It's unlikely that the user acceptance process is going to be thumbs up all around. It's almost always going to kick back a problem or two, and so you're going to continue to iterate on that. So what you want from staging is a clean environment, a clean refresh. You could refresh the same UAT sandbox if you're done with UAT, but you want clean. You want it to start just like production looks today, so the deployment there is the same deployment that's happening in production the next day. What do you do in the case you have a lot of data in production? You can either do this with the dev sandbox only and just use metadata. If you need some data, you can load that in there, or you can refresh. I would give you 10 free sandboxes, full sandboxes. I can't do that, unfortunately. So you have to figure out what data is important and what's relevant to you. Okay. Hey, go ahead.
Yeah, hey, so things are a lot better with the metadata API, but there's still a bunch of gaps. So if I wanted to take a fresh sandbox, I have maybe 50 manual steps that I have to do. So is the implication that those gaps will be filled either by this JSON config file or in some other way?
Yes, we are endeavoring to make the entirety of your application expressible in source control. It's not going to be the situation today where there are all these manual steps you have to do. The goal is to avoid all the manual steps by expressing the whole thing as source.
One of the important things that we struggle with is getting the correct data in the environments when we're going to run our testing. So we've been doing full sandbox refreshes, which is time consuming. And I understand that doing a partial sandbox doesn't always bring down the correct data or the correct relationships. How do you solve for that?
Yeah. It will depend on the situation entirely. Partial sandbox does bring a subset of data. It doesn't necessarily bring the exact right subset. If you're reliant on specific data, you need all of the data for your product and price catalog. I would recommend loading that into the org once you're done, adding a data loading step to get that. You treat that data almost like it's source because it's important to the operation of your application. Hopefully, the tests that you're running in the staging type of environment are unit-style tests that don't rely on the data that's there. But in the case where it is reliant on that for whatever reason, it's probably best to consider the data that you need to have there as source and version control that the same way so it's promoted with it.
I've got a little bit different question, not very technical, but...
Can you microphone? I can barely.
Yeah, the question is like this, because at the same time, we've got those nice features related to the management of the life cycle. Salesforce is also delivering the tools which allows to build some automation outside of this scheme. I'm talking about flows, and you've got still all those things like, formulas and some admins who can do many things. And there is also the question of separation of the duties, if it is well organized. But is there any idea to somehow add the layer of control on those things to keep them, let's say, outside of production and in, let's say, clean environment?
Yes. So we have thought of how, so I've been describing this most from a developer perspective because we're in the developer zone, so I thought it was more on that focus. But to bring an admin in, it's a balance between what you're asking for, which is how can I control that and how can I make sure that nobody deletes a workflow rule that's critical to the business process, and balancing that against how do I enable my business users to be free and able to go, get all the benefits they get when they walk around this conference here and they think, oh my gosh, I can do all this. It's a tug of war. And in different organizations, sometimes those things are on lockdown and sometimes it's the Wild West and the DevOps people have their hair on fire. We are working on ways of making the admin experience feel the way it feels today and yet be a part of a continuous integration process and be a part of the kind of diagrams that I had up here before. So we have ideas, they're still being hatched. I'm guessing by next year, either at our dev conference or at Dreamforce, we will be talking about how we're gonna do it. So we're starting from the foundation. We're making sure that this works for the developers, with people who are not afraid of the command line, getting that foundation correct. And once that foundation is correct, we're gonna start layering things on top and abstracting away some of the complexity so that the admin user can work with the same process.
This may have a similar answer, but so some of the big challenges, we're trying to deploy all of the metadata in our org, and of course the biggest challenges are things like profiles, where one field affects 100 files, and things like flows, where the file name has a version number, so it's tricky to track and deploy in source control. Any big structural changes being looked at to help make some of those things easier and less painful to?
Yes, we are working on a few things. We're trying to break down the monolithic retrieve, which brings you back all the workflows for an object into smaller elements. We're working on a consistency of ordering so that the ordering just doesn't swap on you and make your version control system think you have to deal with a merge conflict. We're working on a few things to try to soften out some of those issues. Some of them are difficult to soften out, and we'll get to them all in time, but we are working on a bunch of different things. Okay. Last question, or we have time for one more? We're done, or one more? Okay. All right, yeah, so you can meet me up here afterwards. Thank you all very much. Enjoy the remainder of the conference.